Good morning, students. The other day, in your live classes, I discussed about the set theory, and then I discussed the operation of set theory. There I told you what do you mean by union of set, what do you mean by intersection of set, what do you mean by complement of set. All those things I discussed with the common examples, and I solved certain problems in your live classes. Today I am going to solve two more problems from exercise 6D. That is question number 6, and one more problem I am going to solve later on in today's class. So first problem, what was there in question number 6? It first there P, there they said P is the set of factors of 36 and Q is the set of factors of 48. First you must know the meaning of factors here. Factors means by which all number 36 is divisible. All those numbers you write. So I have written here 36 is divisible by 1, 2, 3, 4, 6, 9, 12, 18, 36. So these are the factors of 36. That means the element of set P is all those factors of 36. And the second case, the set Q, they said set Q is the elements of factors 48. That means by which all number 48 is completely divisible. The numbers are 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. So these are the elements of set Q. So you got the elements of set P and you got the elements of set Q. And always you must write the elements. And after writing the elements, the first question said P union Q. Union means beta, I told you the other day, you have to add the elements present in set P and the elements present in set Q. Now whenever you are going to add those elements, what are the rules beta? No elements is supposed to be repeated in a particular set or not. So here P union Q, you write all the elements of P and the remaining elements what are not present in Q, those elements will come or not. So what I have done first, I told you can do it whatever way you like. I have written all the elements of set P first, and after writing it I found out there are some elements up to 12. You can see all the elements basically almost except 8. You can see 8 is not common here, 16 is not common here, 24 and 48. So what all elements are not common in this? Those elements from Q I have written it here beta. Now if you want you can arrange them in the ascending order or descending order, or you can write it like this also, there is no problem. So I hope it is clear to you what is P union Q. P union Q means all those elements what is present in P and present in Q, you write them together. But no elements is supposed to be repeat. Every elements will come only one time. Now coming P intersection Q. You know the meaning of intersection. What do you mean intersection is? The elements which are common in P and Q. So elements which are common, the elements which are present in both P and Q, they are called intersection. So P intersection Q, 1, 2, 3, 4, 6 and 12. These elements are present in set P also and Q also. They are called intersection. Next coming beta, Q minus P. The other day I explained you in the class. Whenever you are going to do the minus, what you are supposed to do, please look at me. Q minus P. So you have to compare the elements of Q with P. Now what is the system basically? What are commons between these two right here? Q and Q is common. 2 and 2 is also common. 3 and 3 is also common beta. 4 and 4 is also common beta. 6 and 6 is also common beta. Then what you notice here? Anything else? Yes. 12 and 12 is also common. Nothing else. So after doing it, you can see which all elements are not present in P, because I am doing a Q is first. So after comparing it, my language also you compare both of them. Now you see whichever sets is giving first, Q is giving first. Now you go to set Q and see which are ticked one, that means they both are common. Which one are left over? I am just handling it. These are coming here. See 8, 16, 24 and 48. So I hope it understood. Q minus P means you have to compare the elements of Q with elements of P. Then you see which all elements are common in both the sets. After that you come here, you see which set's name is written here first. In his elements which are not common, those will come here Q minus P. On the other hand, if the question was P minus Q, same thing you compare, then see which all elements of P are not common in both, they are supposed to come. You see which one is the first, according to that you are supposed to do. Next one question is given with P complement intersection Q. P complement. Whenever any complement is given there, this complement means always you have to see whichever complement you want to find out, except his elements, what all elements are present in the universal set or in the union of set. So here P and Q union, all the elements, you got it. Whenever you are going to find the P complement, you just see the elements which are present in P, except what all elements are present in P union Q, they are called P complement. I hope once more let me tell you, whenever you are going to find the complement of any set, how you are going to get it? If the universal sets are given there, so the elements present, except, suppose I cover it up. So elements present in P, you compare with the elements of universal set. So what all elements present in set P, except those what all remaining elements are present in universal set, they will be the elements of P complement. On the other hand, if the universal set is not given, then you always compare with the union, P union Q. Whatever set is there, their union you come, and then you see what all elements are present in P. 1, 2, see here, from you just see 1, 2, 3, 4, see here, come here, 1, 2, 3, 4, 5, 6, up to here, betas. Okay, what all elements are present here? 1, 2, 3, 4, up to here you can see. Look at here. Up to these elements are present in P or not, except those elements, which all elements are present in the universal set, they are the elements of P complement. So always you find out the elements of that complement. Which are there, beta? 8, 16, 24 and 48. So I have written it here. Now they said P complement intersection Q. Now you have to compare the elements of P complement and the elements of Q. Intersection means what is common. So if you come to Q, elements of Q, and if you come to elements of P complement, you will find out 8, 16, 24 and 48 is common in both the sets. They are called the intersection of P complement Q. Alright, I hope it is clear to you. Now I am going to solve question number 9. As that is said there, but if you go to the book, you see the question given A equal to X, and the X is the natural number and the value of X is less than 6. That means set A, its elements are represented by the natural number and the value of the natural number is less than 6. So which all natural number will come? 1, 2, 3, 4, 5. I hope it is clear to you. And then it said set B, all the elements are given there, beta. In set B you can see elements are given 3, 6 and 9. And set C is given there. X, the elements of set C is represented by X. What is X? X is the natural number. And then they have given an equation that C equal to, it is given there, beta. This is 2x minus 5 is less than equal to 8. That means the x is represented by the natural number, and you have to take only those natural numbers. After doing the calculation of that, you should get the value less than equal to 8. Like if I have take 1 as x, what will come? 2 into 1 equal to 2. 2 minus 5 equal to answer will come minus 3. It is not a natural number. If I take x2, 2 is a natural number. So 2 into 2 equal to 4. 4 minus 5 will become minus 1. So that is also not a natural number. So I have taken here 3. Here I am giving. So 2 into 3 6. 6 minus 5 1 come. 1 is a natural number whose value is less than equal to 8. Then I have taken next number 4. So in place of x, what happened here? 4. So 2 into 4, 8. 8 minus 5 equal to 3. Like that I have taken the value up to 6. So 6 into 2, 12. 12 minus 5 equal to 7. Now if I take 7, it will come 7 into 2 equal to 14. 14 minus 5 equal to 9. 9 is greater than 8. So I cannot take it. So I found out all the elements. After getting the elements, what you have to do here? They are given two things, two sides are given there, beta. Okay? One is left hand side and one is right hand side. So I have found out all the values of the left hand side, and then I found out the values of the right hand side, and then I compare and found out after doing the calculation the values of the left hand side is equal to the values of the right hand side. That is why left hand side is equal to right hand side. That is what we are supposed to prove. What I have done here? B intersection C. You know meaning of intersection? Must the elements common in B and C. These two I got it. Next question said A union B intersection C. That means you have to add the elements of A and the elements of B intersection C. So first I have written all the elements of A, and then I found out the elements of B intersection C, and always you remember no elements are going to be repeated. So whatever comes I have written it here. Okay beta? Now the second case what they said, this is the value I got it from the left hand side. Now the right hand side was said that A union B. You know the meaning of A union B? Then they said A union C. I found out the value of A union C. Now they said found out the relation between A union B intersection A union C. That means the common elements of A union B and A union C, which are common 1, 2, 3, 4, 5, 6. I have written the common elements. Now here you can see when you got this here, you got the value 1, 2, 3, 4, 5, 6. Here you also got 1, 2, 3, 4, 5, 6. So what you have been proved, the value of the left hand side is equal to the value of the right hand side. So this is what I am supposed to prove, and I prove it. So if you know the meaning of intersection, if you know the meaning of union, it will be very easy for you to find out. Now I am going to solve the second part of this particular question, beta. Now the second part of the question, what they said? You find out the elements of A intersection B union C and the elements of A intersection B union A intersection C. In the second part what they said you have to prove the elements present in A intersection B union C is same as elements present in A intersection B union A intersection C. So what I have done here, beta, B union C, I got the elements. You know how to find out B union C, it is known to you. Now what I have done it, A intersection B union C, that means the elements common in A and B union C. Which all elements are common? 3, 4 and 6. And the second part of the questions, I found out A intersection B, I found out A intersection C, and then I found out A intersection B union A intersection. That means you have to add the elements of A intersection B and A intersection C. Those two elements has to be added up together. Which all elements are coming? 3, 4 and 5. So what you have to notice? That in the left hand side whatever value come and the right hand side whatever value come, both the values are same. So you can write here LHS equal to RHS. These are very easy, beta. You know how to find out the union, you know how to find out the intersection, you know how to find out the complement, you find out all the elements. After finding out all the elements, if you are supposed to find out the union, you find out the union. If you are supposed to find out the intersection, you find out the intersection. After that, you must see whether both sides the elements are same or not. And if the elements are same, then you can definitely write they are equal to each other. Okay, beta? So I hope it is clear to you. So thank you so much for today's class.